Hi guys, I'm glad to see you. We continue our TechSnacks on topic solid, and as far as today is second event and second topic, this topic will be dedicated to letter O and accordingly open close principle. And um, I want to pass the word our awesome speaker Yevgeny.
Hello, guys. Thank you, Oля. You introduced all topics. Great. So, yeah, today is our second meet, and today we will talk about open closed principle or OCP. I believe we can switch on our screens. Sharing. Thank you. Uh, But before we will jump into this topic, short disclaimer. So during the presentation, I will not able to monitor our chats and so on. So in case you have any questions, please left comments. We will produce it uh, later. And after all our series will be finished, so when we will finish with letter D, we will create a separate event with Q&A. And I promise I will address all questions, all comments during this last event. And in case we will have few minutes at the very end of the session, maybe we will ask one or two questions, but not many. Okay, so let's begin with the solid and open close principles. Let me briefly remind what is solid. Solid, it's a basic software design principle. It means that this principle dictate us how to build and design quality software. And it's divided into five separate principles, but all together works in synergy. And today we will see how it works on the second principle. So, open close principle was introduced by Bertrand Meyer in 1988. I believe you can see how it was introduced. And let's speak. So it's software entities, classes, modules, functions, etc. Could be open for extension, but closed for modification. When I first met this principle, I thought it's easiest thing ever. And that's how I understood it. For example, we have any class, like base class. Here, just example how I understood it maybe 10 years ago, with some set of methods, method 1, method 2, 3, whatever. And according to this principle, we cannot modify this class or entity. But in case we need to extend it somehow, what we should do? Yeah, we should create another class, inherit this extended class from this base class, and when we create subclass, we write the words extends. So everything as described in this principle. And on the very, very basic understanding, maybe that's correct. But if we will dig deeper into this principle, we will see that that's not really correct. That's correct, but not exact. So let's move on to deep understanding of this principle. So now you could see on the screen how Robert Martin described this principle and why it's so important in their article about this open close principle. Um, for example, if you will see it later, you could pause it and read. But what I'd like to highlight, I already highlighted it in red. This principle means that when requirements change, you extend the behavior of such modules by adding new code, not by changing on all code that already works. Again, what does it mean? So, open close principle formally deny any changes in already written code. In case uh, your product owner, your clients, whatever, um, bring new requirements or change existing requirements, you should not modify any source code already written. You you should only add new code. On practice, and Robert Martin also highlighted this, mm, it's almost impossible. So we will change something, but in our systems, we should tend to minimize these changes to protect our high level entities, high level classes, high level components from low level implementation. And how to do this correctly? Um, Key here is abstraction. So let's dive into code example, and then I believe it will be more clear. Let's start for the very basic example. So when I prepared for this talk, I saw this example about maybe 5 or 6 times in different variations. Sometimes it was with rectangle and squares with different kind of shapes, but due to some reason, people like geometry, maybe. So let's dive here. We see just usual class. It's TypeScript, uh, rectangle. So, for example, we have some application which could draw, I don't know, calculate some areas, maybe something for math. Um, Class rectangle just represents usual rectangles from geometry with width, height, and also one public method which calculate area. And that's how we usually write and start designing out our software. For example, we start something with just one requirement. Okay, we need rectangles, and all what we need is just uh, drawing rectangles and calculate area of rectangles. Usual software engineer will write this, create class, so on, so on. But it's not compatible with open close principle. Uh, if we would like to make it compatible with open close principle, we should introduce some abstraction. Here it will be interface shape. Why interface but not abstract class or maybe some just high level class? Because we know another OOP principle that we should prefer composition over inheritance. That's why in all my examples today, I will use interfaces, but not abstract classes. And we will not inherit anything here. So now only one change. So rectangle implements shape. Pretty easy, nothing complicated. Everything else absolutely the same. But now, if we will create another class, for example, circle, the circle will implement also shape, but implementation will be different. Uh, Only one public property and completely different calculation of area. And how it will used? Just some shape calculator or area calculator, new uh, objects like rectangle, circle, and so on, and just in for each calculate area. What's behind this? So now, in case you need to add new uh, shape, you will change only this one place. So you will create a new class in absolutely new file. You will add new line here, and logic will be the same. Everything will be the same. That's here. I tried to create some fancy diagram of this example. Here we see area calculator. That's the last example here. Shape interface and two classes. And according to the open close principle, area calculator protected from any changes in requirements on this level. It doesn't care how many shapes we use, how many functions do we have there. It's protected by this abstraction layer. Only it depends on shape interface and don't care about practical implementation. So we could add anything here and change logic inside circle, inside rectangle, inside, I don't know, triangle, anything, until our classes will implement shape interface, area calculator will work with them without any problems. So let's move maybe to a more real example. That's just notification service. I believe you at least once implemented something like this. Personally, I saw not maybe the same example, but something really, really similar to this. We have notification service. This service just send notification. For now, we have two types, email and SMS. All implementation removed, but just console log with some kind of sending email, sending SMS. That's not compatible with open close principle because our notification service depends on particular message, particular notification types. To protect it from any changes in this low-level implementation, low-level classes, let's introduce again interface. It could be notification, it could be notification aware, notifiable, anywhere. So how it's in your project adopted, so you can name it somehow. But what's important, yeah, we have one method here, send. And now we will rewrite our implementation and create three different classes. As you could see, we add push notification, introduce new notification type here, but all these classes implements our notification interface. In reality, it will be more complicated. Definitely, it will be more complicated there. Some additional logic will be added, so on and so forth. But again, we're interested only in this abstraction. So all these classes should be able to send some notification. Ideally, all classes should be placed in separate files and distributed during the file system. But now it's combined just for presentational purpose. And let's rewrite notification service. So now notification service depends only on notification interface. So you could see that constructor gets not some notification object which implements a notification interface. That's it. It depends only from abstraction, not on particular implementation. Uh, it's sent to private field. One another principle of OOP, you should open your methods, your fields only if it's required. By default, everything should be private. And send notification which use this notification interface send message. So notification service doesn't care how what exact notification type it work with. Just it knows that it's something that could send notification, and that's the client code. So on client side, we can create three different services like email service, SMS service, push service, whatever. New notification service implements it's as we discussed previously. It gets some object notification and it could send it. So you could see absolutely the same structure. Each services call one method, send notification, but in three different methods, different kind of notification will be sent. So email, SMS, push, whatever. What's the benefit? It's clear. In case we will add new notification type, for example, what we have here, push, SMS, email, I don't know, Teams notification. We will add new file with Teams notification, which implements notification. When it's required, we will create new service, but nothing changes. No changes in notification service. No changes in already existing code. Email notification, SMS notification, push notification will not be affected with this new requirement. We just add new class, and all our systems, all our system already can work with this new class because it depends on abstraction, on notification interface, not on particular implementation. On previous event, I was asked about React. And also I heard a lot that Solid, it's about OOP only. In React world, it's not applicable. Basically, that's not correct, because let's move to the very beginning. We could see that any software entities, classes, modules, functions, etc., should be opened for extension but closed for modification. So it's not only about OOP, classes, and so on. Anything in software world can be applied to this principle. And this is the example on pure React. It's almost from real life. I saw this situation many times. One time I saw something really, really similar to this. It was exactly a widget renderer, which get configuration from backend and render widgets in a particular page. And here we have only three, else if. But on reality, it was about 50, maybe 60, but it was huge, really huge. So what's here? We have some kind of dashboard class, which have render widget, widgeted some kind of configuration from backend, front end, hard coded, whatever. And here our dashboard decide what should be rendered based on particular widget class. Probably you already know where is the thing here. Yeah. So again, our dashboard depends directly on uh, particular classes, particular implementations, uh, like chart, table, news, whatever. How to make it OCP compatible? Obviously, it's not compatible because in case we need to add a new widget, we need to modify already existing code, add some logic here, and it might break everything. First of all, let's create a few separate widgets. So each component should be ideally in separate file uh, and implemented absolutely independently. So now we have 3 different components, and that's our abstraction. With OOP, we use it with interfaces. Here, we create components like widget factory. Uh, and that's our abstraction level. Again, let's move to the uh, implementation, how it works now. Again, we accept widget here. It's again something from backend, whatever, but we depends on this widget components and which return particular widget component. We don't know what exactly it. It could be, I don't know, any component, news, charts, diagram, whatever. Now our dashboard don't care about what kind of widget. It depends because it depends only on one abstraction. It's accept it's accept only one dependency like widget component, and dashboard sure that it will return widget as a widget component, and this widget component know how to display it on the screen. So widget component in case no, widget component just return null, and render. Sorry. Render method absolutely the same. No changes here. How it used? Something from backend like widget configuration, dashboard with widgets. Here widget component decide which kind of widget should be returned and initiated. Here our abstraction layer, like a protection, and that's it. That's how our React component from OCP incompatible became closed for extension. Now dashboard, sorry, closed for modification. Now dashboard closed for modification. In case new widget introduced, dashboard will not change it. Nothing will change here. Only we will introduce new component here, and one new component will be added to this factory. That's it. The example from Clear Architecture book. So how this principle contributes and compatible with architecture on high level. We talked about particular object classes. Now we talk about architecture. Uh, Almost everything the same. So let's focus on this part. Financial report generator, financial data gateway, and financial data mapper. Data mapper, it's a particular class or object. Financial data gateway, it's interface. And financial report generator, it's some business logic component which generate required report. Here on this example, financial report generator protected from any changes on database level with this interface abstraction. It depends on interface and it doesn't care about any changes, any modification in database. In case from our solution architect or I don't know CTO came new requirements that database should be changed or another database should be added, all other system will not be changed. So it's protected from changes by this particular interface abstraction layer. It can be not interface, but abstract class, anything, but preferable interface. We could add additional database here. For example, we have Postgres. Let's add MongoDB. Anyway, we will create additional database. Here, we will create, for example, financial data mapper Mongo, which implements this particular financial data gateway interface, and all system will work. And all system will don't care about anything in this place. Um, the same with presenter layer, absolutely the same picture. Controller doesn't care about what particular view will be added because it's protected with these interfaces like screen view, print view, whatever. Uh, so we have 2 minutes. Let's wrap up and let me summarize what we talked now. So OCP or open close principle, it's about adding new behavior. So in case you need to fix something inside your code, definitely you will modify existing code. It's normal. But in case new behavior introduced, new requirement appeared, you should add new code, but try to not modify existing one. How to achieve it? By adding abstractions. And you have to start designing software with abstractions. Identify particular abstractions. Like, I don't know, if you work with automotive industry, it could be vehicle abstractions. And then under this abstraction should be something like car, track, so whatever. Anything. Identify abstractions and build software using these abstractions. As you probably saw, that OCP principle, it's highly coupled with dependency inversion principles. You saw it a few times. I saw that our particular implementation doesn't affect high-level components because everything covered with interfaces. And that's the key. This principle works together. OCP doesn't work without DEP, and DEP doesn't work without OCP. Also, it's about Liskov substitution principle, but we will talk about it next time. And as you see, it's not only for OOP. It's also about React. It's about functional programming, but a little bit different principles. So it's not about classes and inheritance. That was my mistake because I thought about it as an inheritance. OCP principles, it's about dependency management, how you organize dependencies inside your application. So React, OOP, functional programming, whatever, everything can be compatible with OCP principle. I believe that's it. And we are in time. So, dear organizers, could you say me, do we have time for one question? And maybe you saw some interesting questions I could answer, but not more than 2 minutes.
Here is only one question, but it's really huge to read it. Maybe we can take it and answer later in the
Okay.
chat as we agreed at the
Okay,
beginning.
great. Thank you, Ola. Thank you all. That's it. See you in 2 weeks with our Next talk, it will be about least cost substitution principle. Thank you. Bye.